Hi, everybody. Welcome to week 2. Last week, we just did an intro to Python, and which was hopefully at least partially review. And we also looked at lists and sets and dictionaries, which are all going to be important data structures in what's to come. This week, we're going to look at something. The topic is array programming. I've got a little blackboard I'm going to use over here, and I'll post this later where I can jot things down. So this is a new style of programming that we're going to be looking at that is new in the sense that you may not have seen it before. You probably haven't seen it before. It's one that's quite popular in data science and in machine learning. So when you are operating with big grids of data or with many arrays of that are related to one another, parallel arrays of data, as you are in the case of most machine learning and data science applications, it becomes useful to have a language that can treat an array as a basic type. And so popular languages for this are Python with Numpy. So that's one possible, quite popular choice. That's what we're using. The other ones that you may have heard of are R and MATLAB, and you'll see those talked a lot about in the machine learning and data science community as well. But we're using Python with a package, a module called Numpy, which comes pre-installed in Anaconda, which is why hopefully you guys all went with my recommendation to get the Anaconda distribution of Python. And what it all comes down to, or can be sort of explained just by considering what this statement does in most programming languages. A equals A plus B. Okay, so A equals A plus B, generally speaking, we know what that does. If this is a statement in a programming language, we assume that A and B must be variables, and they're usually numeric variables, although the plus operator often works on strings, sometimes even works on lists and arrays in certain languages. So let's take a look at what it does. So if A is an integer, and B is also an integer, then A equals A plus B returns another integer. 12, right? It will also work often in some languages, like I said, where A and B are lists. So if A is a list and B is also a list, A equals A plus B in Python concatenates the lists. Okay, so this is sort of the default behavior. This is, and some languages won't even do this for you with the plus operator. That's about as far as it goes. What would you do if, so A is a list now, let's make B an integer. Now what will A equals A plus B do? So just think for a second about what you think is going to happen. Maybe pause the video, maybe even try it yourself. It's an error. We can't add an integer to a list. But what might we have been trying to do? Well, when you're processing an entire list of data, you often might want to, for example, add a fixed quantity to every item in the list, or multiply every item in the list by a fixed quantity. There are a lot of applications where you might want to process an entire array of data by applying the same operation to all of the elements of the data. Most languages won't let you do that, but array processing languages will. Similarly, when you add two lists together, so A is 1, 2, 3, 4, B equals 4, 5, 6, 7, maybe these arrays represent the number of each of 4 products that was sold in a day at a store. So today we sold 1 of product 1, 2 of product 2, and so on. And then yesterday we sold 4 of product 1, 5 of product 2, and so on. Maybe we want to add those together to find out the total that we've sold in the week. So we want to add these two arrays together. And we want to add 1 plus 4, 2 plus 5, 3 plus 6, 4 plus 7. Well, A plus B in Python concatenates the lists. But in an array programming language, A plus B, if the two lists are the same size, is going to add them element-wise. So it lets you do these operations on arrays that would normally take a lot of programming with loops and what have you, and makes them basic. So to add something to every element of a list becomes basic in an array programming language. To add two lists together, two arrays together, kind of on top of each other, like I showed you, like we wanted to do here, becomes a basic operation as well. You don't have to write as many loops, and it becomes very expressive. If you're doing a lot with data, you can get a lot done in a very short amount of code. So let's take a look at how it works. So we need to import Numpy. When you do an import of a module, so this is a module that's part of Anaconda, what it does is you'll see that Numpy, when it's finished, is added as a module down here. And you can access parts of it by typing the name of the module and then hitting a dot. So there's absolute value, there's an array function in here, and so on. You can call the functions that way. Typically, though, when people are using NumPy, the vast majority of people that use NumPy, I'm just going to restart my shell here, import NumPy as NP. So what that does is it imports the NumPy module, but it renames it to NP to save you some typing. Okay, so let's talk about creating arrays. So one of the first things you can do is, if you have a list like that, so a lot of times you'll retrieve the data from a file or from the user and put it into a Python list, because that's an easy thing to do. First thing, if you want to access the array processing power of NumPy, is you have to turn that array into, return that list into an array. And you can do it like this. So np.array is a function that takes a list object and turns it into an array. Now, Python doesn't normally have arrays. Python just has lists. Lists are flexible. They don't have to be all of the same type. Arrays are more basic and inflexible. So an array, once it's created, can't change its size or its shape, and it's fixed to one type. So an array can only be an array of integers or an array of doubles, unlike a list in Python, which can contain a mix of different types. So what we're doing is so this will only work if there's one type here, or it'll convert things. So now we have A is, when I say what's A, it tells me, well, it's an array, 1, 2, 3, 4. Okay? And now A plus 5, this is what it does. It adds, it doesn't matter if this is an array of one item or of 10,000 items, it will take this plus operation and broadcast it across the entire array like that. And if I have a second array, B equals, 5, 3, 2, 4, like that, and I say, well, first I have to convert it to an array, np array B, like that. I could have done this in one step like this too, or 5, 2, what was it, 5, 2, 3, 4? 5, 2, 3, 4. So I could have done it in a single step by hard coding the list into there in square brackets. So now B is an array, and now A plus B is equal to that. So A was 1, 2, 3, 4, B was 5, 2, 3, 4, and A plus B is what you get when you element-wise add those items to it. So it's pretty cool, and it's hopefully pretty soon you'll see, if you're not already seeing it, that this can be really, really powerful and really expressive. So we should go back and say a couple things. Just arrays versus lists. Arrays are fixed in shape, so lists can grow and shrink, arrays cannot. Arrays have a single type throughout, whereas Python lists anyway, and JavaScript lists and other languages like that allow you to mix and match the types. And they're also indexed a bit differently as well, actually. They're indexed using the comma. I'll show you what I mean. So if you have a two-dimensional array, if you have a two-dimensional list, a list of lists, let's go over here. So x equals, so this gives me a two-dimensional list. Item 0 is a list. X itself is a list with 2 rows. So each row is a list. Okay, so it's kind of hard to see the way that Python prints it out. If I want to print out the 3 here, that's the second element of this list, so row 1, and then in here it's item 0, so it's 1, 0, like that. That's how you index into a list of lists in Python. If this is an array, so I'm going to convert it like this, x equals np array x. Now it's an array. First of all, notice how it prints it out for us. It arranges it into a table, because that's what a two-dimensional array is. This picture is no different in content from this picture, but it's actually it's changed it into rows and columns, because it's common to think of that first index as being the row. This is row 0, this is row 1. That's explicitly shown here. And then the second index is thought of as columns. So this is column 0, column 1. So in a NumPy array, I would pick out that same element like that, x1, 0. And slicing works as well. So let me do a bigger array than this. So two-dimensional array, 1, 2, 3. Let's make it 3 by 3. Comma 4, 5, 6, comma 7, 8, 9, like that. There we go. So now x looks like that, nicely displayed for us. If I want just the first 2 rows of the array, I can say I want rows 0 to 2, or I can just say up to but not including row 2. So that gets me the first 2 rows. And I can say I want all the columns from that row, which is the default anyway. But I can also say I want maybe just the last 2 columns. So here's the original array. I'm saying give me all the rows up to row 2 and give me the columns from column 1 onwards. So it should pick out this little square here with 2, 3, 5, 6. So which is pretty cool, which is something that you can't easily do with Python lists. So I can slice little bits out of here, and I can ask for particular columns. So if I say, I just want x2, that gives me row 2. If I say I want x, give me all the rows, but just column 2. So column means all the rows from the beginning to the end of the list. 2 means just column 2. That gets me 369. That's this column here, 369 has been pulled out. If I want just the second column, I do that, 258. So some pretty cool slicing operators here that are more powerful than the Python slicing operators, and in addition to a bunch of other stuff. So if I say x plus, or x, how about x to the power of 2? That gets me an array which squares all of the elements in it. It's added a d type on here. It's just, you can ignore that. It's just telling you what type of integer is inside the array. Any operation, x divided by 5, will work across the entire list. I can broadcast it across the entire list. I can also do stuff like this. X to the power of, let's do 2, 4, 6. So what this does is if I, sorry, this should be np.array 2, 4, 6. So what this does is these arrays are not of the same size. But since this is the same length as a single row, it will do 1 to the power of 2, 2 to the power of 4, 3 to the power of 6, and then it will repeat that down here. So it broadcasts this row across here, like that. So that produces that. Maybe it's easier to see what's going on with a plus. So if I say x plus that array, so one array plus another array, this was x originally. I added 2 to this, 4 to 6, 4 to that, and 6 to this. 2 to this, 4 to that, 6 to this. So that became 6, 9, 12, and so on. Pretty cool, huh? Maybe? I don't know. It's pretty cool. You'll see how useful it is as we go. What else? So we're looking at two-dimensional arrays now. A.shape. Whoops. So A is this array. Shape gives you the overall shape of the array. So this is telling you that it's just 4 columns. If I go x.shape, it's going to tell me it's 3 rows and 3 columns, like that. So if you want to know how many rows are in an array, you can say x shape 0, that's the number of rows. X shape 1 is the number of columns, if you know you have a two-dimensional array. Alrighty. What else do we want to talk about? Let's take a look at the handout here. So this is the same handout we were using last week, but I'm on page 6 of it here. It talks about NumPy. Oh yeah, so I've been showing you one way to create arrays, which is where you put a list, you give the list to the np.array function. Let's take a look at some other ways to create arrays. Sometimes you want to create an array that is going to have only zeros or ones in it. So that's np dot, so you would say, x equals np dot zeros, yeah. Say 10. That gives you an array of 10 zeros. Notice the decimal. By default, they're all floating point numbers. You can say, give me an array of, and usually you put a tuple here, 10 rows and 5 columns of zeros. And now x has 10 rows and 5 columns, all 0. Same thing works with ones as well. You can also do 3-dimensional arrays and 4-dimensional arrays, but they're harder to visualize, and we're only going to need 2-dimensional arrays for this course, so I'm going to stick to 2-dimensional arrays. So there's a method called zeros, there's a method called ones, which will produce these. There's also ways of producing arrays with random contents. So, so this will give you np.random.randint. You can give it a minimum and a maximum and a size. And the size, just like up here, can be a single number if you want a one-dimensional array, or it can be a tuple or even a list of numbers if you want a multi-dimensional array. So that looks like this. X equals np.random.randint. Let's do 10 players rolling dice. So we've got, we want the size of the array to be each row is a player, and let's say they each roll 5 dice. So there we go. We've got 10 rows and 5 columns of random dice where each row represents a player. And if I do that again, I'll get a different set of random numbers. So that's pretty cool. There's also random, which just takes a size like this, and that gets you random doubles between 0 and 1. And they're all going to be displayed, unfortunately, in scientific notation. So this is 5.75 times 10 to the negative 2. So it's actually 0.0575. That's just the way that that Numpy displays doubles. Can I make it a little better? No, that's the best I can do. Okay, so far so good. We also can use ranges to create arrays. So there's an A range like this, just like the range function that I showed you last week for for loops in Python. So A range 10 gets you 0 to 9. A range 110 would get you 1 to 9. That would get you 1 to 10. And if you want to count by twos, you add a step to it there, and you'll get 1, 3, 5, 7, 9. This is going to be useful. Nothing that I'm showing you here, pretty much nothing I'm showing you, is not going to be used at some point. You may not see the immediate use of it, but you will eventually. Okay, array arithmetic. So if B is a scalar, meaning it's not a vector, it's not a multi-dimensional, or it's not a list or an array or anything like that, it's going to add B to every element of A. If B and A are both arrays and they have the same shape, whether that's 1, 2, or 3-dimensional, it adds element by element. If A is 2-dimensional and B is the shape of a single row, it broadcasts plus B across A. So it adds B element by element to each row of A. That's what I just showed you. And it works for all of these operations, including Boolean operations. So for example, let's do, where are we? A. I'm going to go up to find, here we go. Here's my array of random integers from 1 to 6. I want, if I go x equals 2, I get an array of Booleans where it's true wherever x equaled 2. So down here, the third one in the last row was a 2, so that's true. I could say, you know, x greater than 2, and it gives me a true wherever x was greater than 2. And this is super useful, which I'm gonna show you in a second why this is so useful. So just like you can go x plus 5 and add 5 to every element, you can do this with Booleans as well. So any arithmetic operation, any Boolean, you can do this with. Here's examples of slicing. I sort of already went over this. Here's something really handy. You can index into an array with a list of indexes. Okay, so let's get a one-dimensional array. We'll go from 1 to 100. I'm going to do random numbers. I want 20 random numbers. Sorry, does anybody see what I did there? I missed the NP dot. So there's my 20 random numbers, my array. It's just a one-dimensional array of random numbers. I can say to that array, I can say, give me item 5. I can say, give me item 5 up to but not including item 10. And it gives me a slice of the array. I can also say, if I put a list in here, I can say, give me index 7, and then index 0, and then index 19. So that's index 0, that's index 19, And index 7 just so happens to be 7. 0, 1, 2, 3, 4, 5, 6, 7. That's confusing. But index 7 happens to be 7. So I can tell it, I can have it kind of rearrange and pull out just part of the array like that. I can also do this. I can say, wait, let me make a smaller version of the array, like this. So here's a smaller array, y. I could say, give me, and again, I give it a list. Give me the first one, not the second one, not the third one, the fourth one, and the fifth one. So I'm giving it a list inside this index bar. I'm giving it a list of booleans, and it's just going to pull out the ones where it was true. So this is super cool because let's say I've got an array of items here and I just want the ones that are, let's say, less than 50. I can go give me, if I go x less than 50, I get this array of booleans that is true wherever there was a less than 50. And then I can give that array of booleans. So this looks really weird. Give me x where x is less than 50, and I get all the values from this array that were less than 50. Or x where x equals, I don't know, I don't think there's any repeated numbers, but x equals 7. It's going to give me back just the array where x equals 7. Now that's cool, and there's a lot that you can do with that. So like I said, it's really expressive. Just think about the amount of code you'd have to write in Python to accomplish this, to create a new array or new list that that would have all the elements in it that were less than 50. So super expressive language. Expressive means you can write a tiny amount of code that does a lot of work. Okay, a few other things. I think just going to finish what's on this page here. There's a bunch of summarizing. I showed you a.shape already. There's also min, max, mean, and sum. There's a bunch of other operations that you can do. So here's x. What's the minimum entry in x? It's 7. What's the maximum in x? It's 88. What's the sum of all the elements? These are all methods on NP arrays. And the mean is the average. So that's the average. I think there's a median. No, there's no median. There's no median built in as a method like that. So these are ways of summarizing the data. When you have two-dimensional data, so I'm going to do, let's do again, np.random.randint from 1 to 100. And let's do something different this time. Let's do 5 rows and 10 columns, just to be different. So there we go. There's our data there. If I go x.sum, it's going to get me the sum of the whole thing. But a lot of times what you want, depending on what this data represents, if this again is products, so I want to know if this is a two-dimensional array showing me product sales on day 1, day 2, or product 1 on 5 different days. So this is the week's sales from Monday to Friday. Each row is a different day. This is product 1, product 2, product 3. I want to know total number of sales of each product. So what I really want to do is I want to add the columns together. You can do that by adding along an axis. So you can see there's an optional keyword parameter there called axis. So I can say I want the axis to be axis 0. And axis 0 will cause it to sum along the columns like that. So I get a one-dimensional array out of it that represents the sums of all the columns. If I say axis equals 1, it's going to sum along the rows. So 550 is the sum of this entire row there. And all these methods, sum, min, max, mean, if I want to know the minimum, so for example, min axis equals 0 is going to tell me the minimum number of items that was sold in a day for each product. So it's 3 for this column, it's 16 for this column, 15 for this column, and so on. And if I want to know the minimum across the rows, so on each day, what was the minimum number of products sold of any particular product? Well, it was 4 on this day, it was 13 on the next day, and so on. So that's pretty cool. I can also sort. Sorting, a.sort just sorts in ascending order. I can also sort columns and rows separately using the axis operator, using the axis. So x.sort, so let's take a look at x. If I go axis equals 0, and then look at x. if you look at each column, it's the same data, but it's been sorted in each column. So the minimums are at the top, the maximums are at the bottom of the columns, which is pretty cool. And if I go x.sort axis equals 1, now it's going to sort this way as well. So this row is the same data as this row, but now it's sorted in that order, in ascending order, which is pretty cool. And you can shuffle an array with random.shuffle as well, which is kind of neat. All right, sorry about the edit there. I'm just going to show you shuffling. Import. Made some bad moves there that I don't want you to see. Yeah, if I have an array of, let's say I want to decide the starting order for 5 people, np.arange 1, 6. So there are the people numbered 1 through 5. Now I can do np.random.shuffle indexes, and now they are in a random order. So I've chosen a random order that people will go in. Okay. Oh, this I've already shown you, comparisons with arrays. So yeah, that's cool. Anyway, so that's it for this lesson. I'm hoping that you're starting to see the power of array programming in Python, in Numpy. I want to leave you with an exercise or two. If we go to the exercise documents for week 1 and 2, and we scroll down to Numpy, so write a program that creates a 100 by 100 array of random numbers in the range -1,000,000 to 1,000,000, print the minimum, maximum, and average value in the array. Really basic stuff here. Create a new array that contains the sum of each row of the array from exercise 1. Print the minimum, maximum, and average of these sums, and then combining the arrays from part 1 and 2, print the range of values in the row with the largest sum. So try to do that with as little code as possible. So you create a 100 by 100 array of random integers, then create a new array that has just the sum of each row in the array from exercise 1, and then print the range of values in a row. And you should do this in a file. I wasn't working in a file here, but of course anything I did in the sandbox can be done over here. So I can say x equals np.array 1, 2, 3, like that. And then I can print x and Control-Shift-E to run it. Just a sec, I have an external hard drive that has to spin up before it's going to go. That's what the delay is. There you go. So it runs and it prints out the NP array. So let's do x plus 5. Sorry. X equals x plus 5. Print x again. And it should print it twice, adding 5 the second time. Okay, so this is how you can create your solutions to those exercises. The exercise solutions are posted. Please don't look at them before you've tried the exercises, and maybe even before you've struggled with them, and then ask me for help. It's always better to struggle with the exercises yourself before you look at my solutions. But you should be able to do most of these in just a couple of lines of code. All right, I'll see you in the next video.